Good morning, dear students, and I just welcome all the students to the physics department, Tikpoi College. And today in this video lecture, I will be discussing about average and instantaneous quantities and differentiability. So let us begin. So let us see what is an average and instantaneous quantity. So we will try to understand this, okay? So let me write a simple function f of x, that is y is equals to f of x. So this is a simple function which I have written, and if I draw a graph related to this function, let me draw the graph at first. So let this be the x and y axis, okay? This is y axis, which is equals to f of x, and this is the x axis. Now if we consider a simple graph, suppose the function makes a graph of this type, say, and we define 2 points, say let this be a point which is a on the x-axis, and let this be the another point on the x-axis, let it be b. If I ask that what is the average value of this function f of x between the point a and b, then our simple answer will be what? The slope, or the slope made by the line passing through this point and this point, will give us what? Average value of this function between the point a and the point b. Say here the value of f of x is what? F of a, and here the value of f of x is what? F of b. So as I have said, slope. Now if I draw a line here, say I'm just drawing a line here which is passing through these 2 points, okay? So the slope of this line will be given by what? Certainly change in the y-axis by change in the x-axis. If you see what is the change in the y-axis from here, no, it is something. So this is the change in the y-axis from here to here. And what is the change in the x-axis from here to here? It is, that is del x. So this change simply will give me what? The slope of this line. So that is del y by del x. So this can be further written as what? What is the value of this del y? It will be simply difference of the function f of b minus f of a. And similarly we can write what? Here it's b minus a. So this is the change in the x-axis and this is the change in the y-axis, and the slope will give me what? Average value. So we can write that average value of f of x is equals to simply del y by del x, that is the slope, which is equals to what? F of b minus f of a by b minus a. So this is the thing we have to understand, that whenever we are asked to find the average quantity or average value of a function, then we have to take the change of y, the rate of change of y with respect to x here, okay? Now let me take a real function. Say I'm taking some real function. Say I'm taking a real function f of x is equals to some value of x square. Okay, so this is my function, and for this we know our graph will be what? Hyperbola. Sorry, it's parabola. Our graph will be what? Parabola. So if I will draw a parabola, it will be looking like something like this. Okay, though it is not so much perfect, but still you consider this. And suppose I have given an interval. I'm giving the interval 1 and 3. Suppose I'm giving the interval 1 and 3. So let this be the x is equals to 1, and let this be the x equals to 3. Just consider, okay? Though the numbering is not so much perfect, but still you consider. And here our function will be what? What will be the value of? This will be value of f of 1, and here the value of the function will be f of 3. So the average value will be here. This is the y-axis, this is the x-axis. So the average value will be here given by the slope, as I have said. Or you can simply say the average quantity will be given by the slope here. So this is my slope. Now, what will be the average value? Average value will be what? Rate of change of y-axis with respect to the x-axis. So what is the change in y-axis with respect to x-axis? So we'll be writing what? F of 3 minus f of 1. And here we'll be writing what? 3 minus 1. So if you see, so 3 square is what? 9 minus 1, and here it is 2. Simply we are getting 4. So this is the value that we get as the average value. Now let us try to understand instantaneous quantity. Suppose that I want to find at a particular point the value of the function. Okay, say at a particular instant of time. Say suppose I want to find it here. Say suppose I want to find it here, and here the value of x is how much? 2. Say it is 2. So what I am going to do? I will approach the value of the x from 1 to 2. I will be approaching in this direction. Let me take the red color to represent this. So I will be approaching in this direction from the left hand side. I will be approaching from this direction from the right hand side. That is, from 3 to I will come to 1. From 1 to I will come to 2. Okay, I will start approaching towards this 2. Toward this particular instant at x equals to 2. What will the value of the function? F of x. Okay, so certainly as along the x-axis, as we will be approaching towards the 2 from these two values, the function will also approach towards this particular point. Okay, so let us see. I'm just drawing this. Okay, say that the closest value to 2 we take for the x-axis, that is, say for 1, let us approach to 1.9. Okay, this is my closest value, x along the x. Okay, and from 3 I am approaching, and let the 3 reach to the closest value 2.01, not 01, 2.1. Say from the left hand side, that is from 3, we are approaching to the 2, and the value of the closest approach is suppose 2.1, and from the left hand side, as we are approaching from 1 to 2, the closest value to 2 is 1.9. Okay, so what is the value we are going to get at that time? We can see that if we take this, that is f of 2.1 minus f of 1.9, and here it is 2.1 minus 1.9, we will see that the value of the x, it will become very small. What is the difference between these two numbers? If I ask, it is 2, 0.2. So the value of x is approaching towards the 0. If you can see, it is very close to 0. And at the top, what we are going to get, if you just use a calculator, I am using the calculator here, okay, and directly writing the value. So I'm directly writing the value here, that is 4.41 minus 3.61. So if you take the difference of these two, we'll be getting here 0.8 and it is 0.2. So what we are getting? We are seeing that we are getting the value 4. That is, for f of 2, if you just put it here, f of 2, we will be getting here 4. So this is what we are getting, and this is the instantaneous quantity or value of the function at a particular instant of the time. Okay. Now if I draw a tangent at this point, that is f of 2, then I'll be getting something like this. Okay, so this is the tangent at this point, and the slope of this line or the slope of this tangent will give me what? Instantaneous value of the function at this x is equals to 2, that is f of 2. So therefore we can write the slope of this line will give me what? Instantaneous value or quantity of the function, okay, at this particular point, that is x equals 2. So we can write what? Instantaneous value of a function f of x can be written as limit del x approaches to 0 del y by del x, okay, or this can be written as limit del x approaches to 0 and f of b minus f of a by b minus a. So this is how we represent, and this is also a slope of the tangent at this particular instant. So this is what instantaneous quantity is, and we have already seen what is an average quantity or value of a function. Now let us try to understand differentiability. So after having the concept of instantaneous rate of change of a function, let us try to understand one more thing, that this instantaneous rate of change of a function f of x is also called derivative of the function. So this we must know. It means what? That derivative of a function, suppose this is the function f of x, its derivative, I am just denoting it by function prime, okay, is equals to instantaneous rate of change. A function f of x. So what is this instantaneous rate of change? We have already learned, that is limit del x approaching to 0 del y by del x. This is the average, and this average becomes instantaneous when we limit the function to a particular point or when del x approaches to 0. So this is what derivative of the function. So this can be further written as limit del x approaching to 0, f of, say the interval is b, minus f of a by b minus a. Okay. Further, this can be also written as derivative of the function f of x equals to limit h tends to 0 f of x plus h minus f of x divided by h. This can be also represented by this. Let us try to understand this form of the derivative of the function. So let me draw the graph again. Say this is the y and x axis. Okay. Let this be the y axis. Y is equals to f of x, and let this be the x axis. I am taking a very simple graph this type, and let this be the interval between which I am finding the derivative. Let it be a, and let this be the point b. Let this be the point b on the x-axis. Here the function will be what? F of a, and here the function will be f of b. Now I want to find, suppose at this particular point c, I want to limit the function at this particular point c. So the function will be approaching to this point, that is f of c. Suppose there is small increment in the c, and that increment is how much? It is h. Suppose at this point let it be c plus h. Okay, so this is the small increment along the x-axis at the point c. Suppose h is that increment, so our function will become what? F of c plus h. I can write that f of c plus h, and this f of c plus h is very close to f of the c. So the function at the particular point c, here I didn't take any particular point, I have taken x. Okay, so if you just consider this point as x, and there is small increment in the x, so I can write in this way. So if I write that derivative of the function at the point c is equals to what I have to write? Limit. Since h is very small increment in the x, and it will become more smaller as x will be approaching from the right hand side to the point c. H will become smaller, and it will approach to 0. So limit h approaching to 0, and here we can write, instead of x I will write c plus h minus f of c. So can you imagine the difference between f of c and f of c plus h? It is h. So as h becomes smaller, this difference will also become smaller and smaller. And here we can write h, which is a very small quantity, or you can say simply del x is equals to h here. So this is very small change in the value of the x. Okay, so this derivative of the function at a particular point c can also be represented by this format. So that's why in the, since I am taking a variable here x, so I have just represented this in this format. Okay, so this is what a derivative of the function mean. So we have to apply this. Suppose you are approaching from the left hand side now, from this side. So if I consider a small value of h, suppose I am approaching here, and let this small difference between this point and this point be h. So what I can write here? c minus h. The point coordinate will be c minus h. Okay, and so my function will also become here what? F of c minus h. So for the left hand limit, I can also write in this way that f of derivative of the function at point c is equals to limit h tends to 0 f of c minus h minus f of c by h. I can also write in this way. Fine. For the right hand side we can write this, and for the left hand side we can write this. Now tell me one thing, that can I write the derivative of the function at point c equals to limit x approaching to c f of x minus f of c x minus c? Is this true? Yes, it is true. If you just try to see this, that is as x approaches to c. So as x will approach to c from both the sides, the function f of x will also approach to the point f of c. So the difference between the function f of x and f of c will become smaller, smaller and smaller, and it will approach to this point f of c. Okay, so this is also a form for derivative of the function at particular point c. Thus, if f of x be a real valued function defined on an open interval a comma b and c belongs to the open interval a comma b, then the function f of x is said to be differentiable at x equals to c if and only if limit x approaching to c f of x minus f of c divided by x minus c exists finitely. So you must say this term finitely. You must see if this becomes infinite, then it is not differentiable. Remember, it should be finite. So we can write that is derivative of the function at c is equals to f of limit x approaching to c f of x minus f of c by x minus c. Fine. So this is the concept of differentiability, or when a function is said to be differentiable. Okay. You must also remember one thing, that if a function is differentiable at a point, right here, you must remember this point, that if a function is differentiable at a point, it is necessarily continuous at that point. So you must remember this point, that if a function is differentiable at a point, it means it is continuous at that point. Okay, but the inverse is not true. Fine. So this is all about the concept of differentiability, and in my next video lecture I will try to solve some problems based on this differentiability. So for today only this much. That's all. Thank you.